The idea of changing elements into gold is rooted in both historical alchemy and modern nuclear physics. While alchemy sought to transmute base metals into gold using mystical or chemical means, which was not scientifically viable, modern science shows that transmuting elements into gold is possible through nuclear reactions, though it's highly impractical. Below, I'll explain which elements are easier to transmute into gold, focusing on scientific principles, and keep it concise. Gold's atomic structure. Gold is element 79O on the periodic table, with 79 protons in its nucleus. To change another element into gold, you must alter the number of protons in the nucleus via nuclear reactions. Easier elements, elements closest to gold in atomic number, protons, require fewer changes to their nucleus, making them easier to transmute into gold, though the process is still complex and energy-intensive. Mercury, Hg, atomic number 80. Why? Mercury is the closest element to gold, with one more proton than gold, 80 versus 79. Removing one proton, via neutron capture followed by beta decay or proton emission, can theoretically produce gold. Process. Neutron bombardment can convert Mercury-196 into Mercury-197, which can undergo electron capture or beta decay to become gold-197, a stable isotope of gold. Historical example. In 1941, scientists like Glenn Seaborg bombarded Mercury with neutrons in a cyclotron and detected trace amounts of gold. Challenges. Requires a nuclear reactor or particle accelerator. The yield is tiny, and separating the gold is difficult. Mercury's toxicity adds practical issues. Historical note. Alchemists often used mercury in attempts to make gold, unaware of nuclear processes, but their experiments were chemically ineffective. Platinum, point, atomic number 78. Why? Platinum has one fewer proton than gold, 78 versus 79. Adding a proton, via nuclear reactions, can produce gold. Process. Proton bombardment or neutron capture can increase the atomic number. For example, platinum-198 can capture neutrons and undergo beta decay to become gold-197. This has been done in small-scale experiments in particle accelerators. Challenges. Similar to mercury, the process is inefficient, costly, and produces minimal gold. Platinum is already valuable, so transmuting it to gold is economically pointless. Thallium, Tl, atomic number 81. Why? Thallium has two more protons than gold, 81 versus 79. Removing two protons is theoretically possible but harder than with mercury. Process. Neutron bombardment followed by multiple decay steps could convert thallium isotopes into gold, but this is less studied and more complex. Challenges. Thallium is further from gold, requiring more nuclear changes, and is less commonly used in such experiments. Proximity to gold, elements with atomic numbers close to 79, 78, 80, 81, require fewer protons to be added or removed, reducing the complexity of the nuclear reaction. Stable isotopes, mercury, platinum, and gold have stable isotopes, e.g., gold-197, which makes the resulting gold less likely to decay into something else. Historical precedent. Mercury and platinum have been used in successful, though inefficient, lab experiments to produce gold. Energy costs. Nuclear reactions require massive energy, e.g., particle accelerators or reactors, far exceeding the value of the gold produced. Low yield. Only trace amounts of gold are created, often mixed with other isotopes, requiring costly separation. Economic reality. Mining gold or recycling it from electronics is vastly cheaper than nuclear transmutation. Elements far from gold, e.g., lead, iron, or carbon, are much harder to transmute because they require significant changes to the number of protons and neutrons. For example, lead Ipb, atomic number 82. Alchemists famously tried to turn lead into gold, but lead's nucleus requires multiple proton removals, making it far less easy than mercury or platinum. Light elements, e.g., carbon, oxygen. These have very low atomic numbers, 6, 8, requiring extreme nuclear fusion or fission processes, which are infeasible. The easiest elements to transmute into gold are mercury and platinum, due to their proximity to gold's atomic number, 80 and 78, respectively. Mercury is the most studied for this purpose, with historical lab successes. However, the process is so costly and inefficient that it's not practical compared to extracting gold naturally. If you're asking about a specific context, e.g., alchemy, a sci-fi scenario, or a lab experiment, let me know, and I can dive deeper.